It's useful in social science, in medicine, in law, in a lot of areas like that. So the application is very wide. So inshallah tonight. So let me proceed to. So now, uh, can you see my slide on my screen? Or somewhere?
Yes.
No, okay.
Yes, you can see it.
Okay. Thank you very much. So I started as I said that my background is in meteorology and climate science from FUTA. I'm not like a geospatial science student, but due to, I started as an environmental activist and not like a student. So, but due to some of the environmental issues that we noticed in the environment during my undergraduate days in FUTA, that is when we started the environmental activities. Like we try to move to some area to make some campaigns, talk to people about what to do. But I think in 2019, I have the privilege to do my internship in I did one intern in a National Space Research and Development Agency in Abuja, NASDA. So then I was able to introduce to GIS and remote sensing tools. So, and I feel like, okay, since we have some background in environmental and climate science, this is an opportunity and avenue for me to just like bring these tools to even make it more easier for me like to interpret and like show some things from what is going on the field. So that's when we started like, okay, when we get some data from open source, like maybe like some satellite, we can use to show some maps, some one or two things. And also this is one of the things I would like to like advise some of the people listening to joining this webinar. It's very good whenever you are doing anything. Let people know what you can do, because then when I started my the geospatial the programs, I don't whenever I do any map, whenever I make any map, I try to like put on my Twitter account. So from there, that is where some people try to like, okay, can you do the map for us? So they tell, okay, can you do, okay, I'm going to like tell my professors to, you can work with them, something like that. And they're trying to like make some money from it. So the journey started from the environmental uh, actions, try to solve some environmental issues. Then I'm trying to think, okay, how can I combine the geospatial knowledge to it? So these are some of the pollutions in our environment. Uh, we see this is after whenever it rains in some places in Nigeria. If you can see my pointer, this is Ogunpa River in Ibadan. This is Lagos and some other places. With GIS and remote sensing, this can be solved uh, with the tools. Now, going forward, this is me. One of my curiosity also as a researcher, though I'm not a GIS expert, I'm a student. I try to like reason that, okay, is there a way we can try to inculcate like the GIS tools, like maybe to some the secondary school curriculum to some students, so that they can learn more about these tools before even going to university? Because I notice these days, I'm now seeing some students now. Yeah, I met two, three students like last week. I asked them, what are you doing for your master? They said they are doing GIS and remote sensing as their masters. And they have the background in like chemical engineering. I think some maybe another field, I could not remember. So if you have some of our mentees or brothers and sisters, we can tell them to try to focus on some of these area like GIS, meteorology, and other fields instead of moving through medicine, mechanical engineering, something like that, because these tools, these courses, they are applied to varieties of field. At the end of the day, you can work with World Meteorological Organization, World Health Organization, and a lot of United international organization like that. So this is one of my curiosity about how we can try to bring the things together. So we still have a lot of things. So I'm going to like move forward and go straight to today's topic. So I'm just trying to use that one like introduction. So inshallah, and we're talking about geospatial analysis. We have to talk about GIS, remote sensing, geospatial analysis. Because when we're talking about geospatial, spatial space, it has to do with space with location on Earth. So, sorry, let me shift this thing. So when we're talking about geospatial, we have to talk about GIS, we have to talk about remote sensing. So these are some of the short definitions I was able to come up with. When I talk GIS, it stands for Geographical Information System. That is just the acronym GIS, and if we start for so when we are talking about GIS, this is a computer-based tool that analyzes and displays data that is linked to a specific locations. It's like a tool, our desktop. That is the GIS tool. So the remote sensing, which is the second part, I came up with this definition because I noticed that I searched for many definitions online, but the word art is missing. But I could remember from my university days, they used to put this art. They said it is an art and science. And the reason why it is an art is that it's this with colors, colors. So this because the red, okay, this it is an art and science of obtaining information about Earth's surface from a distance using satellite or aircraft. For example, I'm going to use example of our remote sensing, like our remote. We used to control our television, our television and TV set at home. We can stay some distance far from the television by just pressing the button. We're able to like control the TV set. You're able to control the TV set. So this is how this remote sensing it works using that approach. So it's not going to it's like the process of acquiring informations about an object without being in physical contact with that object. So for example, you have some satellite in space. They takes information about oceans, land surfaces, and other areas like that. They are not going to interact with the object or the surface like physical, but they take objects through electromagnetic spectrum. So we are still going to talk about that along the line. So now the next one is geospatial analysis. So what is geospatial analysis? So this is a process of examining and interpreting data that are being collected by maybe this remote sensing on other platform with a spatial component to uncover patterns, stress, and relationship across geographical space. So it's cut across like techniques like statistics, cartography, and all. So, sorry. Okay. Okay. So, are we? Okay.
Mm-hmm.
Okay. Can you hear me?
Okay. Okay.
Hello?
Yes, we can hear you.
Okay. Thank you. So now moving to the next phase. So we have as I'm talking about remote sensing, this remote sensing, I say this is the process of collecting information without being in physical contact. So now this is satellite. These are the satellite that are in space. Satellite, for example, this is NASA Earth Science. They have Landsat 1 to 9. For example, people that are in like a natural science field, they will be familiar with some of, or they have heard about this Landsat 1, 2 to 9. The latest one is the Landsat 9. So we have Landsat 1 to 9. These are satellites, they are in space, and we can we can acquire data from they acquire data time to time, and they orbit around the Earth at different time intervals. For example, this I think Aura 2022, it used to it this with maybe like in air pollution or something. I know air pollution monitoring or something like that. So they have different specific information they are doing, like Terra, Aqua, a lot of information they takes in the space. So they are working independently. So, okay, so Landsat 1 to 9. This is the Landsat 9, which is the latest. So now, also, another one was developed by the European Space Agency called, this is Copernicus data set. So you have, we're hearing about something like Sentinel-1, Sentinel-2, something like that. So this is the one developed by the European Space Agency. And the resolution is quite different from that of Landsat from NASA. I think this one's around 10 meter, like medium uh, resolution. We are still going to talk about that, inshallah. So now we are talking about satellites. We know satellites, they are in space. So satellite, they can be categorized based on how they gather and transmit data. So we have two. It can be passive or it can be active. So sorry. The passive means that this satellite, for example, you notice that sometimes when we look up into the space, we used to see like a cloud. So this cloud, they used to affect the way this satellite, they acquire image or they acquire informations from the Earth surface. So sometimes, and also maybe when the sun is not reflecting to the side the satellite is passing through. So it's going to affect the way it acquires information. So we have passive sensors. These sensors, this satellite, these are the one that relies on the energy from the sun. So in order to observe and measure Earth surfaces, so they detect and measure energy that are reflected from Earth surface during the day. For example, the Landsat, MODIS, and Sentinel-2. So the other one is the active sensor. So they have their own emission. They have their own energy source to transmit signal. They did not depend on sun to acquire image. So which means that they work 247. So I think you have new one like the synthetic aperture radar, like this SAR satellite. So they are using like the application is like in monitoring and disaster responses, something like that. So they work 247. So, okay. So now, the- moving forward, so geospatial data. So, okay, before I move forward, let's just do some, I don't know if you, sorry. Uh, Hello, Assalamu alaikum.
Alaikum salam wa
Alaikum salam. Can hear you.
Yeah, okay, thank you. So I just want to like, let's do like a virtual tour, something like just to know what we are talking about because so that it's going to like soundboard for people that are not from natural environmental science area. So for example, let's say we want to do a research about let's say for example me from environmental science, I want to do a research about land use, land cover. I want to know what has changes over some certain times in this particular area. Let's say, for example, in Ibadan. So I want to do a research in Ibadan. I'm in Manchester now. So I want to do research in Ibadan. So and I need to know maybe just to check the area I want to do research about. So it's possible for me, I can send someone to go to this area, but another way with the help of this geospatial data, I can do something called virtual tour. So without leaving where I am, I can check, I can go to this area remotely to check what is going on area. So I'm coming on. Okay. So this is what we call Google Earth Pro. This Google Earth Pro, let me just cancel it. I checked this area before. So this Google Earth Pro, we can check some area without even leaving our, okay. So sorry, let me just open it again so that we can see the way it works. Okay, so this Google Earth Pro. So with this Google Earth Pro, I can check some area without leaving where I am. So then I'm going to have like some insight about the area. So, please, can someone just tell me one area we like to like check? Hello?
Hello,
Yes,
Right.
I'm like, um,
can you
now,
check Abaroje in Lagos?
what do you call it? Abba?
Abaroje, ABA
Uh-huh.
Ranje.
R R
Ranje.
uh-huh. J okay. Okay. So can you see now Abaranje Road? So once I press it, you see this thing now. Can you see the box? So we are going down to Abaranje in Lagos. So now we are now in can you see it now? Hello?
Yes, yes, yes,
Hello?
yes.
So if you
I can
notice
see it.
something, if you notice something, aha, so we can zoom to this place to see it very well. But if you notice something, you see that this place, it's an urban area. There is a little no vegetation self. You understand?
Yes, yes.
So we can have some insight about this area that Abaranje is an urban area. There is no vegetation. So another way to do this, so let's do another thing now. So let's go to our Google. We used to use this one every day, but just Google Map. Google Map. Then, so from Google Map, I want to check Abaranje again. So, sorry. Uh, Abaranje, Lagos. So I want to check Abaranje. Mommy, do you know this house? Okay,
What?
let's check
Okay.
this. Uh, sorry, just a moment. Mommy, do you know this place?
Not quite, not quite sure.
But this
Maybe
is,
we should enlarge it.
do you know this side? But this is
Yes, yes, yes,
uh,
yes.
uh, so these are the
Okay,
I've not been to Abaranje. I don't even know where is Abaranje, but I can have some view about these places without even living where I am. You understand? So these
okay,
are the advantages
okay,
of
okay.
geospatial science or geospatial analysis. So let's go back to where we are before. Now, can you see my screen now? My slide, rather.
Yes, yes.
Okay, thank you very much. We are talking about geospatial data. This is known as geodata. In short, it is geodata. It's an information that describes the exact location of an object on the Earth's surface. So there is no place on Earth, like two places on Earth that can have the same longitude and latitude. They will have different latitude and longitude, different one. You understand? That is geospatial data. So the picture beside there is like a map. The one below is a base map. So we can overlay different data on it. We can overlay imagery, we can overlay land cover, wetland. When we do some practical before the end of this thing, we are going to have more ideas about it. So, okay, let me just move forward. So when we're talking about geospatial data, it's of two types. We have the raster data and the vector data. So when it's raster data, so the way they taught me is that when they say raster data, what should come to our mind is we're talking about images. So when it's vector, it's either be line, polygons, or vector. So one of my aim tonight is that I know this might be new to some of us, but at least each and every of us should learn one thing, like one new thing, and we should be able to teach other. If it is this raster, difference between raster and data, that is the only thing we're able to like learn to now. Alhamdulillah. So, but let's just follow up, and I'm very sure by God's grace we are going to learn more than one thing. So now, raster data, when they talk about raster, what should come to our mind should be like we are talking about image. So now they said raster, it represents the real world as a grid of equal size cell or pixel. So each place on Earth surface, it's used to represent them with some grid, like a grid, small box. So it's for example of this are like satellite imagery, which we are going to see. elevation models, and something like that. So the five formats that it used to come is GeoTIFF, NetCDF, and others. So for vector, sorry. So now for vector data set, we have as I said earlier, it's point, line, or polygon. So, for example, Abaranje in Lagos. So, Abaranje will be in maybe one local government. That's a point. So, it represents certain points. So, let's move forward. So now, so raster image and raster data and vector data. So raster, as I said earlier, they are continuous data. They are continuous in the sense that they can be transformed to other parts. So for example, the grid cells I'm talking about, this is this small box. So they are like grid of cell or pixel, small cells. This is raster. So vectors, they are like they are discrete. For example, what we call vector is like the line, like road, it's a vector data. River is a vector data. Line, road, vector. Rivers, they are vector data because they are in forms of like polygons and other things like that. So for us to acquire, whenever we are doing our research that involves satellite data, we need to have put some things into consideration, which are like the resolutions, like four things should be put in consideration. The spatial resolution, the spectra, temporal and radiometric resolution. So when we are talking about the spatial resolution, we are talking about the size of the smallest of the pixel that can be detected by the image. We are going to see the example in the next slide. So the spectral resolution, it involves the number of bands when we are doing some calculation, the algorithms. Also, the temporal resolution. The temporal resolution it depends the number of the times that each satellite that it orbits the planet. So that is the temporal resolution. For example, I think Landsat, it will be like every 6 days. So there are some that will be like 24 in 24 hours. So they have different temporal resolutions. So you have to put this into consideration. And also the radiometric resolutions, which refers to the sensitivity of a remote sensors to variations in the reflectance. So for example, now this is going to be more clearer in this slide now, what I'm saying about the four resolutions. I don't know if you can see my pointer. So where I'm pointing to now, the high spatial resolutions, we have high spatial, medium, and low. For this one, you will notice that you can see this image very clear. So this is a little bit blurred and this is very blurred. So now, the reason that this is high spatial resolution, it has a resolution of around 1 to 3 meter, between 1 to 3 meter. It is very small and it's very clear. So this high spatial resolution, they are commercial and very expensive. So they are used to do some specific analysis, like monitoring like some specific area and other things like that. So why this medium resolution? They can be used to do some maybe like global analysis or something like that, like maybe monitoring like urban growth or something like that. So the Landsat and the Sentinel that I show in the beginning of the slide, so they form around this medium resolution, around 10 to 10 meter, like that, or 10 to 20 meter or 30 meter for Landsat. So low spatial resolution, I think Moody's, they are in this like 500 to 1 kilometer. You say it's difficult for us to see the image clearly. So now we're talking about the wavelengths now. So this wavelength now that we are talking about, it's very important because we are talking about bands in geospatial analysis. Bands refers to the narrow range of wavelengths that are that's assigned for specific use cases. For example, these bands, it works like the electromagnetic spectrum. So it's the electromagnetic spectrum in the satellite, which ranges from uh, I think from X-ray to gamma ray. So this box, this wavelength bands now for the satellite image. I think this is a so it have different functions, and it provide information about different areas. This first one, which is the coastal and aerosol, it monitors the coastal and aerosol part. So this blue, green, red, this is the parts that our eyes are visible to, also in the electromagnetic spectrum. So the near infrared, this is used to whenever we are doing like all this analysis that involve like uh, vegetation index, water index, something. So you have to use near infrared also. So the shortwave infrared one and two, they are used to do analysis like when we want to do something like that involve algae blooms, oil pollutions, and something like that. So when we move forward, we are going to see how we can combine these bands together to get good insights. So geospatial use cases. Uh, geospatial use cases, this is the way for geospatial analysis. This is the way the analysis is being done. First, we have to understand the problem we want to solve. So when you understand the problem you want to solve, this is going to assist us to know the data that we want to use. For example, the Landsat images 1 to 9, they have different years of existence. Also for the Sentinel 1, 2, and 5P, like that. So they have different years of their exist. It Let's say we want to do research from that is going to start from year 2000 to 2000 up to date. So I'm going to use it's not possible to use Landsat 9 because Landsat 9 was released in 2020. So we need to check for data that covers that year. So, and also when we are doing analysis, we should combine data that they are of the same resolutions, or they are of the same functions. So that is data acquisition. So we need to process our data because some data they can have there are some missing values, outliers, and there can be like atmospheric corrections if they are not being corrected before. So with that, we can do exploratory data analysis, use the geospatial tool to analyze our data, and we do models, then we deploy and we do the visualization. So moving forward, so there are some vital skills for geospatial research. If you want to do, sorry, if you want to do research in the geospatial niche, first we need to know some things. It is important to learn some programming skills and language. For example, Python is very, very important. We are going to do like a short practical using Google Earth Engine. So it is the Earth Engine was written in JavaScript. So, but these days people are doing analysis with Python from Google Earth Engine. So it is good to learn one, if not all. So they are almost of the same thing, but it is good to know one. So for the data analysis, and because this will help us for visualization and model development as well. So for the analysis, so ability to clean, once you know this programming language, it gives us the privilege to analyze our data, to be able to clean, to explore, and also to analyze the data using some of this approach. Also the spatial analysis. So knowledge of this spatial data is going to like allow us to extract insight from location-based information. Lastly, it is good not only for geospatial analysts, for everyone to have efficient writing and verbal communication skills to be able to present our findings with other people. So now, these are some of the geospatial data visualization we have. We have QGIS. I'm going to show us how to download this. It's open source, it's free. But this one sometimes it can require us to have a license before we can use it. So Saga, GIS, and other geospatial tools. So now, there are some of the applications where the geospatial analysis can be used. For example, when I'm searching the internet, I think this afternoon, I was able to know some people have used GIS to carry out research in dermatology, which has to do with skin. So we know of in microbiology, this during the COVID era, a lot of dashboard was being created to visualize the COVID-19 this thing, the trend in COVID-19 and how the health worker can go to different areas to provide support. So also, we know of precision agriculture. This is GIS and remote sensing are being used in this area. Also in construction industry, building, GIS is being used. Okay, in precision agriculture, this is for land degradation and monitoring. Also for in food industry. So for pest and disease control, soil quality assessment, climate impact analysis, supply chain management. Also in social science, in law, it can be used to in a lot of places. It's used to like traffic, all these car tracking and a lot of things because anything that deals with location, these tools is important in that area. So these are some of the places where we can source data, geospatial data sets. So we can source from different varieties of area. So before I go to this place, I'm going to do one or two okay. So let me start with, sorry, I just want to, okay, let me start with, uh, or can I know, hello, Assalamu alaikum.
Alaikum salam
Why
wa
salam fine?
Please, can I know maybe if you can type in the chat, but maybe some of our research area, I think that's going to give me, so that I can know what to, yes, this thing. Sorry, okay, now. Air pollution. Okay. Is the a raster vector? Okay. Please can we come to drop our question? Urban heat climate change. Okay. Now. Okay. Now. Thank you. So now I'm seeing some comments. Sorry. I want to. Okay. So now for the urban heat, I think for example, this, let me copy this. Okay. I think this is on flood. I don't know if anybody is on flood. Urban heat island. Okay. Okay. This is on flood. So this is one of the, how can I push this? Okay. Yes, sorry. Then, so I just want to show us one or two application of this. So this is one of the okay, I'm seeing another question. Okay, flood risk. Okay, I'm going to start with the flood risk now. So if you see now, I'm hoping one of the project I did for my in one of the tasks I have. So now we are able to use this GIS and geospatial approach to do flood susceptibility mapping. So if you can see my screen now, how can I make this thing? if you can see my screen now, this is flood susceptibility mapping using the weighted overlay analysis. Sorry, I can be mentioning some strange term. So I was able to focus on Kogi State. So this uh this platform I use, it's called Story ArcGIS Story Maps. It works like PowerPoint. So you can put your now. Hello. Okay, you can work. So this is the work. This is the introduction. So I'm not going to waste time on this place. So now this is on flood susceptibility mapping. You can see the area. This is Kogi State in Nigeria. If you are familiar to this place or if you have been to this place. So I started with a study area map. What we call study area map. This is the map that shows the location or the area where we are working, where we want to concentrate. So this is Kogi State in Nigeria. I'm going to do one demo on how we can extract some specific area from our map. But because of time, I'm not going to have more things. So now, this is the methodology that was used. I followed approach of another paper. So if you see, this is I think this is the elevation map of the area. So from this, then I think I was able to do this. So don't let me waste time on it. I just want to go to the last part. So these are the data set that was used for this research. So these are some of the maps that was made from it. Then after that, I use this weighted overlay approach to do my research. Then after, it's a long process. I can give you a link to this if you want to explore. Then this is the final map that was produced after the work. So now, from this is Kogi State in Nigeria. You can see that from this legend, they said very high. This is the area that are very susceptible to flooding, maybe due to the elevation of the area and other factors. So the following one is high, followed by this green part, which is very low. You see that area like this Kotongura, Ajakuta, like they are very high source flooding from this analysis. So this is one of the application of geospatial analysis in flood to do flooding the research. So let me try to open another one. Because of time, I'm sorry. I have to go very fast. So now, this is what we call, okay, let me go to QGIS. So this is one of the tools that I showed the other time that I said is used for visualization. It is called QGIS. It is open source. It is free. If you want to do anything in QGIS, either we are from natural science or other part, we need to have access to this software. So I'm going to provide the link on how we can download it. It is free. So, so once we are in this place, it has different layers. So we can, this is the project. We can view our data set. We can do a lot of things. So this is the interface. Now, for example, if I have the Nigeria admin, huh? Okay. So let's say, for example, sorry, because of time, that is why I'm trying to. So. I don't know why this thing is going. Please share the link. I will share the link. Don't worry. Sorry, I have to deselect the feature. So now, can you see this Nigeria map? Hello.
Yes, you can see it. Yes.
Okay. So now, let me try to label this feature so that it can give names to. This thing. So show label. So now, I'm so just a few minutes. I'm coming. Okay. So I think we are still going to. So now we have different areas in Nigeria now. This is Edo, or I'm from Oyo State. So now, let's say I want to do research in Oyo State. So, but for us to know more about this data set or how to navigate or explore it, so once you have your QGIS, you load your data set. I'm going to provide link to where we can get all these data sets. They are free and they are open source. So once you right click on this, you can go to properties. So once you go to properties, you can read more about these the data sets. No, sorry. You can go to attribute table. So attribute table is like like something that is telling us more about the data. So it shows that now you see that when I click the label before, everything was Nigeria, and this is because I'm using name 0. So once I switch to name 1, I was able to like see the areas, different areas. So now, is this from OpenStreetMap? No, it's from Diva GIS. So now I want to extract Oyo State from this map. So now once I go to this, I right click, then I can go to attribute table. Once I switch to Oyo, I select Oyo. Once it's been selected, then it will highlight automatically. So for me to extract Oyo from this Nigeria, I can right click again, then I will say that I want to like export map. Then since it's been selected, I'm going to choose selected. So I want to select from save selected. So I can just give it a year. Then you choose S3 shape file, then we go. So that's it. So we have the Oyo State now. So for us knowing that maybe we are doing something that is right, there's another file that is called OpenStreetMap. Someone just asked of this. So once I click on OpenStreetMap now, is automatically, this is a layer that is available. I want to show that Oyo is being projected well. So now you see that this is Oyo, which is close to, I think, close to Ilorin, something like that. So these are one of the ways we can do. So let me go to another site to show us the other. So I think I can go to this NASA Power now. So let's say, for example, that I want to work on heat map or something like that. From this website, which is called NASA Power. So we can have access to some other data. Let's say we want to do research in maybe biochemistry or chemistry that has to do like all these soil data or temperature, rainfall, or physics. Then we can go to NASA Power. So the data is also free. Is it possible to get statistics of the quantity of product particular to? Yes, I think we can get this from okay, I will provide
So
response.
you can go ahead. There is room for question and answer.
Okay, thank you very much. So now this is NASA Power now. So this NASA Power, we can have access to a lot of data from this place. Then we can, because I don't know if you notice when I'm talking about vector and raster data set. So our data set can be in CSV. We are familiar with CSV. This is comma separated values. This is what we use in Excel. So this data set, it can, and this NASA view and NASA Power, it gives us the privilege to have access to this CSV file. So let's say I want to work with get data of maybe like temperature or precipitation from Nigeria. So this is the link to NASA Power. Then we can just move to Nigeria. I think Nigeria is here. Okay. So this is Nigeria. This is Nigeria. Sorry. Then this is region. So it's regional data I want to do. So now I click on region. So once you click on region, then you can now come down to this user community. Sorry. So we select the community, then you can, okay, renewable energy, agroclimatology, sustainable building, the one you want to do. So let's say I click renewable energy now. Then the temporal level. So the temporal level, as I talked about temporal resolution, it has to do with anything temporal, it used to do with time, the interval, how often that thing. So the temporal level now, you want to, is it daily, is it monthly, annual, or climatology? When they are talking about climatology, it's something close to like 30 years or above, something like that. Let's drop our question. Okay. So
So you
now,
have 5 minutes more.
how many minutes?
5 minutes more.
Okay. Sorry. So now, let's pick monthly and okay, no, let's pick daily. So now I selected daily. Then for me to get the location, as we are talking about geospatial data, we talks about latitude and longitude, but it's difficult. I can do it manually by going online to search for the longitude of the area I want to do. But another method is that I can just, okay, I can use these rectangle tools to draw over this area, that this is what I want to do. Once I draw over it, it automatically filled the box by itself. So, and I think I can adjust this thing. I'm sorry. Okay. So now I'm extend. Okay. Okay. So now I can now go to the date I want to start from. This is the start. Then let's just do something very fast. July 24. Then maybe to October 2024. Then the parameter we need. So we need this is renewable energy. Then we can now check for, maybe we want to get photosynthetic active, something like that. Then I can say, okay, I want to pick another one. That's all. So now, once we are done with the data we want to use, so the last one is to select the format. So as I told you, we can choose CSV, which is good for our analysis, because this can work with Excel, or you can use NetCDF if you want to work maybe like Python or other thing. But let's just use CSV. So once you check the CSV file, or the particular specific format you want to work with, once you submit, it's going to ask for your email. Then the data set will be sent. It will give you, after submit, you have the options to download and save your data. So that's for the NASA this thing. So let's explore another one, which is called natural health. So this is for people working, because I saw some people saying so.
Sodiq, please, can we take questions, and maybe during the question we can explore the other ones as an example? I don't know if
Yeah,
that
okay, no
is
problem. Yeah.
fine. I think there are some questions in the chat box.
All right. Let me just go to okay. I'm already okay. Mm, uh, where should I start? Is DM okay? So I think Brother Rashid Bello, I said is DM a raster or vector. So DEM is raster data, because I told about the grid of cell or pixel. So and it had to do with when I said how you can easily know raster is based on the anything that has to do with image. You understand? So the digital elevation model does not has it has nothing to do with maybe like line, points, or polygons. So it's automatically a raster data set. Fish tox. Okay, somebody talks about fish toxicity. So for fish toxicity, so this is when I'm talking about this for this type of research. you can work with something like it's because of time. There's another one I want to introduce, which is very simple and straightforward, but it requires us to have some basic knowledge of coding. So it's called Google Earth Engine. So Google Earth Engine is a platform that we can do some analysis. All these RG blooms, you can do your analysis without even install any software. It's open source. It's online. You can just like go to Google Earth Engine, then you can easily do your analysis there. You see your result, then you save your output. So valorization of plant wastes. Flood risk assessment. I think I've done this. Okay. Food economies. For food economy, okay.
No, those ones are not questions. It was when you requested for a topic.
Yeah. I know. I'm just trying to like provide one or two things to it. So I think the question is coming in now. So Brother Rashid Bello said, sorry, it's because of time. I think the time is too short for me to, so that is something I need to meet. So Brother Rashid Bello said, what did you call the website again? Okay, I don't know if you, so the one where I did the analysis, it is called, what is it? Sorry.
By junction.
Hello?
100.
Someone,
Yes, sir.
so it is called story maps. It's not for analysis, but it can give you can do your presentation, you can easily, it's like just for visualization. It makes your work very perfect and you can do a lot of things there. So I'm going to provide the links to the work, then you can explore it as well.
There's another question. Is Google Map information same as Google Earth Pro? And how current can the information on Google Earth Pro?
Okay, thank you very much for the question, Sister Jamila. So Google Map information and Google Earth Pro, yeah, they are different. Because, for example, for Google Map, it's not going to show you some informations like maybe like the topography of some area, but on on Google Map you can only see I think the satellite view, the like, but yeah, but on Google Earth Pro is basically for like you can do some assessments, some more analysis or some other stuff on it that Google Maps is will not be able to do. You understand?
Okay.
I don't know if
Thank
I'm
you.
okay.
I have a question.
All right.
Okay. Thank you for the wonderful session. My question is, if we are to project a map for a study area, let's say you are working with fish farms in different locations, how are you going to represent them using this GIS?
Please come again. Sorry.
If you're working on different farms
Okay.
from
Okay.
different location, and you want to like your study area, and you
Now,
are to project them using this GIS.
now.
So how are you going to do that?
Okay. Yeah.
Is it the same procedure?
What do you say?
Is it the same procedure since
Yeah.
it's not a single location?
Okay, I think one of the way you can do is that if you have like a different different storage area, it depends on you. You understand? For example, let's say I have like two fish farms, one in Ibadan, one in Lagos. You understand? You can do. It depends on you the way because it's like a map. You are the one that want to present. You can say okay. This is map A for fish farm in Ibadan. This is map 2 for fish farm in Lagos. It depends on you the way you want to do it. There is a way on the map you can, if it's because of time, if there is a way we can like have another, so that we can just do something. It can be like how to create maps. So it's not going to be like I will start from beginning. You can
What
create,
I'm saying is, let's say for example now, you know Rita Bele very well in Akure. So you
yes.
have two to three different farms in the same Rita Bele, and you want to locate them on the map.
Ah, okay, I got it. I get it. So now, so in that kind of scenario, you are going to use one map, just one map. So now on your legend, the legend is going to be the one that's going to now show different points. You know, that kind of this thing is going to be like you are doing like a vector data. It's like a point map. You understand? You can use just different symbols to differentiate this area. Maybe you can use star for one. You can use like a circle for. So your legend is going to be the one with star. It's fish farm one. You understand now?
Okay.
Is Google another person said it's another person. Okay, thank you very much. You don't need to pay to access Google Earth Pro. It's free. Once you able, it's free. It's free. You can just download the data source and the data set and install on your system. Once your system is I think 8 gig upward because it's very heavy and it used to slow down. I'm
Can we
sorry.
generate that using the QGIS you mentioned, and is it free?
What do you say?
Can we generate like the farm question I asked? Can we use the QGIS to
Yes, very
generate
well.
that?
Yes, I'm going to share the presentation and I've put a link to where you can install the QGIS. Once you click on
Okay.
the link, you will see how to install the QGIS. It's straightforward. So because of time, we don't have more time. So, but I will just advise us, please. This is like as someone said, it's an eye opener. And this is the way me too I was introduced to these tools. But let's try to like explore further on ourselves. You can go to YouTube or Twitter to learn more about this. And I pray Almighty Allah is going to make it.
Jazakallah
Mo jẹ́rìí ẹ̀.
So, do you have
Jazakallah
any
khairan
question? I
for
think
this.
somebody is raising up his hand. Brother Rohim.
Okay, do you have question, Rahim?
A question is on the chat box.
Wait, let's
Can I speak now?
Yes, you can. Please go.
All right, Assalamu alaikum. So,
Why?
Jazakallah khairan. Many thanks to Professor Sadiq Abayomi for the job well done. I mean, I personally, I'm from the field of agri-food and environmental economics, and one of the key things that always spur my interest in learning to do the basic things, because when you ask students to go to field, most especially for those that are doing data collection, we have a gross academic dishonesty going on amongst our students, because sometimes they fail to go to field, they cook data in their room and all those stuff. But I know that with the power of coordinates, if you choose a location that you're supposed to go to Ipokia or go to Yewa North local government, I know that the coordinates from that Yewa North local government can never be the same with Alabata in Abeokuta or being in Abeokuta South.
Exactly.
So, and for each household that you visit, that you take the coordinates at the point that you are doing your interview, one can bring those coordinates together and develop a map to pin all the places that these people have visited. So if you say you are visiting, then you want to collect data from 200 people, and the data point is showing that 50 people, are you saying that 2 people are living in the same location?
Yes.
When you have your selection methodology or the sample technique that we have used. So that is one. The second part that I always also want me to learn more about this, that though priorities, so many conflicting interests at the moment, is you can't call yourself an environmental economics, and you don't have basic knowledge of all this spatial analysis and all those stuff, because most of environmental issues now have been looked at on a global level. My current PhD research is working on identifying factors that we can use to build household resilience to climate shock. Now, to measure climate shock, people will use self-reported, whether people experience shock or not. And also, we're exploring the options of, okay, let's use historical data to see the anomalies, extreme weather cases. If you experience flood like 2 times of the standard deviation, that means that you experience flood. If your rainfall volume is less than, maybe you experience drought, and if your temperature increases and all those stuff. But if you don't have knowledge of all these things, and unfortunately, your household that you are using is not close to weather station, but with the help of this spatial analysis, you can approximate the nearest location of the weather station to the household that you have that this thing, then you can find a way to extract the weather, the temperature or rainfall information for over the years. But in short, it's for those of us that we are in environmental economics or whatever, or even any part of economics, is one of the skills that I think personally that I need to venture to make sure I acquire more skill about this. But many thanks for the presentation. Like the person I've said, is an eye-opener, but it's not just eye-opener alone. It's something that is making us to crave for more, and to maybe I will reach out to you. Definitely, I'm searching for you on LinkedIn already.
No,
I'll reach out
no,
to you, then we'll
Mahmoud,
see
you can
how
you can talk on
better we
WhatsApp.
can collaborate. Thank you so much, Jazakallah khair. And thank you for to the organizer also. May Allah bless every one of us.
Jazakumullah khairan. Barakallahu fikum. All right, sir.
Yeah,
Thank you very much. All right. I think
Jazakallah
we have
khairan.
more
So,
time.
I think, will you be sending us the copy of your presentation?
Yeah, sure. Very well. I will send to the group, and maybe before I send, I can add some other links and try to write few things. So on how to
Okay.
install and have access to the data set, so that it's going to make it easier for us to navigate. So
Okay.
as I said, please don't let us stop here. We can explore further and try to, because I think this afternoon I was able to find some of journals that in fact people have published on some works out GIS in specific field. So we can read journals, we can watch
Yeah.
YouTube videos and other things.
Yes. Thank you very much. I was just about to also mention that because of time, you could not show us like different examples for different research area. So one way that we can try to explore how to use GIS for our research area is looking for published article relating to this. And we might be lucky, we can see from published article where they tell us the methodology they use, the software they use, and how they go about it. So with that, we can use that one to also learn how we can incorporate that in our own research also. And if Allah permits, we can try to organize a longer version of this, which will not be part of our monthly discussion, but we'll see if we can do something like that also. Jazakallah khairan again. So thank you very much. We can
All right,
end
thank you.
today's session.
No, all right.
Okay, at this point, we just end today's session, inshallah, and next month we would have another topic where we'll discuss something that is relevant to our research community, inshallah. And with that, I would say Jazakallah khairan to everybody who participated with your questions and your problems, solutions, and everything. So thank you very much. Assalamu alaikum. See you next month.
Alaikum salam wa rahmatullahi wa barakatuh.
Wa alaikum
Wa
salam.
alaikum salam.